Okay, so today we'll start on probability. So I'll just run through it see with regards to probability and give you a general overview of probability. Okay. So firstly, in this whole term of probability, okay, what is it? It's just this mean where in an experiment or in any scenario, which they like to call an experiment, okay, there are always different outcomes. So in this case, for example, let's say we toss a coin. The possible outcomes are only head or tail. So there are only two possible outcomes. Okay. So in this case, what they are trying to do is this, for example, we are trying to find out what's the probability of you getting a hit or what's the probability of you getting a tail. Okay. So ignoring that it lands on the side. And in a normal coin, okay, the probability of you getting a hit is 50%. Or what we'll put it as half. Okay. So in the same way, the probability of you getting a tail is also half. So probability of you getting a head or tail, that will be half. Okay. So how do we write it? Is in this case, where ultimately the probability of an event, which they usually write it in C and C inside the bracket. So that itself is asking for the probability of itself an event. Okay. So firstly, let's say we are finding a probability of event. How do we calculate it? Basically, it's number of favorable outcomes over total number of equally possible outcomes. So in this case, the number of favorable outcomes in let's say tossing a coin, number of favorable outcomes, let's say run a kid. So out of the two outcomes, head and tail, we only want one outcome, which is hit. Okay. So the total number of equally possible outcomes, so the total number of possible outcomes are head and tail. So the probability, the possible outcomes are 2. So in this case gives us our probability of getting a hit, which is half. Okay. So next is this is in an event where something that is sure to happen, something that will always happen, okay, the probability of an event will always be 1. So for example, the probability of you getting a head or tail and tossing a coin is definitely 1 because there are only two sides, either head or tail, and obviously getting either of those sides is definitely 1. Okay. So next is that in a impossible event, there's something that won't happen, is the probability of this thing will be written as 0. So for example, is that the probability of you getting both head and tail at the same time is impossible. So it will definitely be 0. So for anything that happens, okay, for any probability for any event, okay, the probability will always be within a range of 0 and 1 and 0 and 1 inclusive of it. Okay. So as we have learned before in our previous chapter, there's this prime. Okay. So in this case, for example, let's say the probability of E prime, okay, which for example, let's say E is, for example, that we want hit in the coin toss. Okay. E prime is basically you do not get hit, do not hit, which in this case is tail. Okay. So in this case, if let's say we want to find the probability of E prime, which is the probability of tail, or in other words, not hit, what we can use is 1, which is the maximum probability, minus the probability of you getting a hit. So in other words, it becomes 1 minus the probability of us getting a hit, which is half. That itself will give us half. So in other words, what we're saying is the probability of you not getting a hit is half. Okay? Moving forward, there are two different events, okay, or 3 different events, okay. So in this case, it's this first event is mutually exclusive. Mutually exclusive are just things which cannot occur simultaneously. For example, you can't have head and tail at the same time. Okay? So those are mutually exclusive. So in this case, the probability of A occurs or B occurs. For example, the probability of head of our probability of tail that occurs, how do we find the probability? Is use union, which in other words, we are adding the two probabilities together. Okay. Next is independent event. It means that, for example, we toss the coin twice. What is the probability of you getting both hits? So ultimately, both events, you tossing it first time and you tossing it second time, whatever result is in the first time does not affect whatever result we have in the second time. So for example, first coin toss, we get a hit. Our second coin toss, even though our first coin toss we get a hit, our second coin toss is still equal probability of us getting a hit. Okay? Which in this case, both are probability of us. So in this case, we're asking and checking what is the probability of you getting hit twice in both coin toss. It will be a intersect, which in other words is multiply. Okay. So in this case, the probability of you getting hit twice is half multiplied by half, which gives us 1/4. So the probability of you getting hit twice is 1/4. Okay. And this lastly is this dependent event. So in this case, this dependent event is basically, let's say, event that occurs, let's say, something which happened in the first one affects the probability of us happening in the second one. So for example, let's say we have 10 sweets. Okay, 7 of them are red, 3 of them are blue. Okay, so in this case, the probability of us getting the red is 7 out of 10. The probability of us getting a blue is 3 out of 10. Okay, so let's say we have this event where you take out 2 sweets, and every time the first time you take out, you eat it. Okay. So in this case, for example, let's say the probability you want to find out the probability of us getting 2 red sweets. Okay. So the first time when we take the red sweet out, it will be a probability of 7 out of 10. But after you take the red sweet out, you are left with 9 sweets. And out of 9 sweets, 6 are red, 3 are blue. So the probability changes because now we have 9 sweets. So now the red is 6 out of 9 and blue is 3 out of 9. The probability changes. So in the second time, the probability of us getting a red sweet is 6 out of 9. Okay? So in this case, the probability of us getting red sweet twice is 7 out of 10 multiplied 6 out of 9. Okay? So in this case, the probability changes every time we take out the sweet. Okay? So this is your dependent event. So these are your 3 different types of events that can happen in the probability. Okay. Next is this. In this whole probability, in this whole probability portion, what we will normally do is we will draw a probability diagram or T diagram, whichever you like to call it. Okay. So in this case, how we will draw is this. So let's say we go back to the coin toss, where there are only 2 probabilities, which is head or tail. Okay. So how do we draw this probability diagram? Or how do we draw this tree diagram to display this? Firstly, based on the number of probabilities, or more based on the number of outcomes, we'll draw the branch. So in this case, based on coin toss, there are only 2 probabilities, almost 2 outcomes, 2 possible outcomes. So there are 2 branches. So first, we'll draw the 2 branches. And at the end of each branches, we'll draw, and more we will write what is the outcome. So first, the head. Second, the tail. So to me, in this first coin toss, okay, then we draw 2 branches, and lastly, we need to include what is the probability of us getting each of those outcomes. So in this case, the probability of us getting a head is half, probability of us getting a tail is half. So if you actually see, these two are mutually exclusive events. So which means those two can't happen at the same time. So in this case, our probability of all outcomes should always add up to 1. Okay? So in the second coin toss, ultimately, we have to draw the next layer, which in this case is our second toss. So we draw a head and tail. Same thing, head and tail. Okay? So in this case, based on our first coin toss, it does not affect the probability of our second coin toss. So each of it is half as well. So within each of it, it adds up to 1. Okay? So in this case, any of it, let's say we wanted to have our first coin toss to be head, second coin toss to be head as well. The probability is half multiplied by half. So we take the first probability multiplied by second probability. Same for the tail, head first and tail being the second coin toss is half multiplied by half. Same for all. So each of it should equal to 1/4. And if you realize each of it, after you add them up, it will come back. It will come back to 1 as well. So this is how we display our probability tree diagram to show our different possibilities and our different outcomes and the probability of them happening. Okay, so that's our overall portion of this probability diagram. Okay, next is to move on to the question. So for this week, a total of 10 questions. Okay, so run through each of it. For each of any of it you get wrong, I believe that's what you'll be looking at as well. Okay, so moving on to the question, it says here the table shows number of Sec 3 and Sec 4 boys and girls who are sport leaders. Okay, so it shows in this table. So they say 2 sport leaders are chosen at random to represent the school in an amazing race competition. Find the probability that both the sport leaders chosen are girls. Okay, so in this case, we just need both to be girls. Okay, so if we were to calculate, so in this case, this is a dependent event because after we chose one, we have to remove one person out of the total. Okay, so in this case, our first pick, okay, this is our part 1, our first pick, the probability of us getting a girl is 17, which is the total number of girls, out of 30, which is the total number of students. Okay, and our second pick, okay, because we have taken out one girl from the first pick, our total number of girls is 16. Our total number of students is 29 now. Okay, so in this case, any of it, the probability of us choosing both girls is 17 out of 30 multiplied by 16 out of 29. And that should give us 136 over 435. Okay, so that's the probability of us picking both girls in this case. Next, part 2, where ultimately both sport leaders chosen are from the same level. So both must be Sec 3 or both must be Sec 4. So it can be either both Sec 3 or both Sec 4. So we got to calculate the possibility and the probability of both. So let's say if both are Sec 3. Okay, our first pick, the probability is 16 out of 30. Our second pick, it will be 13 out of 29. Okay, same as in Sec 4. Our first pick would be 14 out of 30. Our second pick would be 13 out of 29. So both probabilities and both are possible because they reach the criteria of same level. So in this case, if both are sec 3, the probability of us getting both sec 3, it would be 16 out of 30 times 15 out of 29. It will give us 8 out of 29. So in this case, if both are sec 4, the probability of us getting both sec 4 will be 14 out of 30 times 13 out of 29, which should give us 91 out of 435. And ultimately, since both are possible, we add both probabilities together, which gives us 8 out of 29 plus 91 out of 435, which would give us 211 out of 435. So the probability of us getting both leaders from the same level is 211 out of 435. Okay? So next, we'll move on to question 2. Okay. So in this case, the table below shows the number of students in a class. So they have a right-handed, left-handed, and boys and girls. So in this case, they say that a student is chosen at random. Find a fraction in its lower term, the probability of student that is a left-handed boy. So in this case, first thing, you want to find out how many boys are there. So there are a total of 20 boys and there are a total of 15 girls, which gives us a total of 35 students. Next, we want to find out how many people are left-handed and right-handed. So in this case, there are 14 right-handed and 21 left-handed. Okay, so with all these numbers, it will help us a lot in calculating. Okay, so in A part 1, they want you to find the probability of you getting a left-handed boy. So in this case, the left-handed boys, there are total of 12 and there are total of 35 students. So in this case, this itself gives us our lowest possible probability. Okay, so that's for A part 1. So for A part 2, the probability of us getting a girl. So there are total of 15 girls and there are total of 35 students. So that should give us a simplest form of 12/7. So the probability is 12/7. Okay, so next is this. The probability of us getting a boy or not left-handed. Okay, so first thing, you want to find out the probability of boy first. We want to put in the probability of boys first, which there are total of 20 boys. Okay, and we want to find out those who are not left-handed. Okay, so those who are not left-handed, they are total of 21, but we have already included the boys in. So whatever that's left with are just the girls. So we will only add in the girls who are not left-handed, which in other words are right-handed. So which are 6. So same thing out of 35, which that will give us 26 out of 35. Okay, so that's our probability of us getting a boy or not left-handed. Okay, so next, part B part 1. Okay, they say that 2 students are chosen at random. Okay, just to take note, because in this case, 2 students are chosen at random, which means that when we pick the first student, we have to minus 1 from that group. And our total number of students increases by 1 as well. Okay, so in this case, they are asking the probability of us getting both boys. So in this case, the probability of us getting boys in the first time is 20 out of 35. And us getting boys the second time, since we remove 1 boy, it becomes 19, and the total needs to be removed by 1. So in this case, we multiply them together because both are independent, both in this case, this is a dependent event. Okay, so 20 out of 35 multiplied by 19 out of 34, and that will give us 38 out of 119. Okay, part 2, B part 2. So in this case, 2 students are chosen at random and neither of them is a left-handed girl. So neither of them is a left-handed girl. So in this case, there are 2 ways. Okay, so we can find the total of those who are not left-handed girls, the probability of it, and we multiply together. Or we find the probability of left-handed girls and use 1 minus it. So in this case, what I'll do is I'll use the first method, which is find the probability of us getting not left-handed girls for both sides. So in this case, the number of not left-handed girls is 24 out of 35, because those who are not left-handed girls are under right-handed boys, left-handed boys, and right-handed girls. So the only number that we're removing are the nine left-handed girls. Sorry, it's 26. Okay. So the probability of us getting not left-handed girls is 26 on the first time. Same thing, minus 1 for both. And that will give us 65 out of 119. Okay. So those are our answers. Okay. Question 3. So a survey is conducted in a school to find out which of the 5 countries, namely Japan, Korea, Thailand, and Taiwan, as the student preferred vacation destination. The pie chart below shows the result of the survey. And certainly we have the pie chart. Okay, so there's a different angles that is being stated there. So first thing, with the pie chart, what you want to do is you want to put it in our probability, in terms of probability, in terms of our fraction. So in this case, Korea is right angle, which is 90 degrees, which gives us 1/4. Japan, 60 degrees, which gives us 1/6. China, 15 degrees, which gives us 1/24. Thailand, 145 degrees, which gives us 29 out of 32. And our remaining Taiwan, we use 360 degrees minus all the remaining degrees, and then from there we can find the probability. Which in this case, Taiwan is 50 degrees, which would give us 5 out of 36. Okay, so we have indicated each of the probability of each of the countries, which help us a lot easier. Okay, so in this case, first part, A part 1. They ask for the probability of selecting a student who prefers Taiwan. So we just choose one student, there will be 5 out of 36. Okay, A part 2. It says China or Korea. Okay, certainly these two are mutually exclusive. So what we got to do is we got to add them up. So it'll be 1/4 plus 1/24. And that will give us 7/24. Okay. B. James claimed that less than half of his school students prefer neither Thailand nor Japan. Okay. So less than half of his school students prefer neither Thailand nor Japan. Means less than half of the students don't like Thailand or Japan. Okay. So in this case, how do we calculate? So in this case, what we can do is we can add up the probability of all the countries except Thailand and Japan. And from there, we find out is it less than half. So in this case, we don't add Thailand and Japan. So we just add Korea, which is 1/4, Taiwan, which is 5/36, and China, which is 1/24. And that will give us 31 out of 72. So in this case, it shows that less than half prefer neither Thailand nor Japan. Yeah. So in this case, it shows less than half. So his claim is correct. Okay. So next, part C. They say that 180 students prefer Japan and 180 represent our 1/6. Okay. So in this case, they say two students are selected at random from the school. Find the probability that only one of them prefer Japan. So in this case, we know Japan is 180. Our total is 180 multiplied by 6, which is 1080. So those who don't prefer Japan is 900. Okay. So in this case, 900 people don't prefer Japan, 180 people prefer Japan. So we need to find the probability that only one of them prefer Japan. So in this case, two students are picked. So what we can do is this is that first student prefer Japan and the probability is 180 over 1080, and second student don't prefer Japan, which is 900 over 1079, because we have chosen and picked up the first student. So the second possible way of happening is that first student don't prefer Japan, which is 900 over 1080, and second student that has been taken out is the student that prefer Japan, which is 180 over 1079. And with that, we multiply each of it and we add them together. And that will give us 300 over 1079.
Okay, so moving on, we'll move on to question 4. So in this case, it says that bag 5 contain 5 balls with number 1, 3, 5, 7, and 9, and bag 5 contain 5 balls with numbers 2, 4, 6, 8, and 10. So a bag is when a ball is randomly drawn from each bag, and the sum of the two numbers on the ball is obtained. So firstly, they want you to complete this possibility diagram. Okay. So ultimately, in this case, or the first number among the first ball that is from bag A is added with the second number that is drawn from bag B. So in this case, we just need to add the numbers together. Okay, so we have completed our possibility diagram, okay, by adding the number from bag A and the number from bag B. So in this case, they ask for the probability that one number drawn is a prime number. So in this case, our prime number are 3, 5, 7, 2, and that's all. So only this four numbers are our prime numbers. So in this case, our prime numbers, okay, where the probability of it being one of it being a prime number, it can be both, but as long as one of it is prime number, are we need to take this column from 3, 5, and 7, which gives us a total of 15. Okay, and adding on is the column from number 2. So those additional columns which are not being added in would just be this 2. So that itself gives us a total of 17 boxes. Okay, out of our total of 25 boxes. So the probability of us drawing one number being a prime number is 17 out of 25. Okay, moving on, part 2. The sums are perfect square. So in this case, we just need to calculate how many of it are perfect squares. Where ultimately 9, the number 9, okay, where there are 4 nines, and that's it. Yeah, there's only one perfect square, which is 9, and there are total of 4 nines. So in this case, 4 out of 25. That's our probability of it. So B part 3, the sum and one of the number drawn are odd number. Okay, so the sum must be odd number, which in this case, all the sums are odd numbers, and one of the number drawn are odd numbers. And in this case, every number, almost every sum of it, one ball will be drawn from bag A, which are odd numbers. So in this case, every single thing hits the criteria of sum being odd number and one of the number drawn being odd number. So in this case, it is 100%. So in this case, this is a sure event. So this probability of it is 1. Okay, moving on. Question 5. Okay, so basketball team plays 2 matches in a tournament. The outcome will be either win, lose, or draw. So there are 3 different outcomes. So the probability of wins each time is half. The probability of lose each time is 1/3. So they want you to draw the tree diagram. Okay, so in this case, there are 2 matches. So there must be 2 layer of branches. So firstly, there are 3 different outcomes. So there will be 3 branches. Win, lose, and draw. So our win is half, our lose is 1/3, and the remainder is 1/6. So our draw must be 1/6. And next, this is our first match. Okay, so in this case, of the results of our first match does not affect the result of our second match. So in this case, this is an independent event. Okay, so same thing, win, lose, and draw. Since the probability of since the result of first match does not affect our second match, the probability stays the same, which is half, 1/3, 1/6, and same for the other one. Win, lose, draw. Half, 1/3, and 1/6. Same for last one. Win, lose, draw. Half, 1/3, 1/6. Okay, so this is our probability diagram. Okay, so based on this is our second match. Okay, so based on this, they want you to solve the question. So our part A, the calculate probability that the team win both matches. So ultimately, this is an independent event. So what we need to do is we multiply the probability together. So the probability of you winning the first match is half. Multiply the probability of you winning the second match, which is half as well. So the probability is 1/4. Okay. So part B is this. The probability that the team wins once and lose the other. So in this case, there are 2 different there are 2 different ways that this happens. Where firstly is the team win the first match, loses the second match, and second possibility is the team loses the first match and win the second match. So in this case, with that, we need to add up both the probabilities together. Okay, so in this case, if the team win the first match, multiplied by the team loses the second match, and we add the team loses the second match, I mean, the team loses the first match multiplied by the team loses the second match. So in this case, it should give us a probability of 1/3. So the probability of the team win once and loses the other match is 1/3. Okay. So part C, it says the team loses none of the matches. So in this case, there are many possibilities. Okay. I mean, in this case, there are many possibilities where ultimately every loss is should not be included. So in this case, it means that team wins once and wins the second one, or the team wins once and draws the second one, or the team wins once, I mean draw once and win the first one, I mean wins the second one and draw second, I mean draw first match and draw the second match. Okay, so in this case, there are four different ways to achieve this method where the team loses none of the match. So in this case, same thing, we need to add them together. So the team wins once, wins the first match and wins the second match, plus the team wins the second match, I mean wins the first match and draws the second match, plus the team draws the first match, wins the second match, and the team draws the first match and draws the second match. So ultimately this, we just need to add them together. And that should give us 4/9. So the probability of the team loses another match is 4/9. Okay, moving on. Question 6. Okay, so in this case, uh, in a box, there are 14 blue marbles and 6 green marbles. 2 marbles are drawn at random from the box, one after another without replacement, which means after it's being taken out, the total number decreases. Okay, so in this case, we need to complete the tree diagram. So, uh, the probability of us getting, or for the first marble, probability of us getting blue is 7 out of 10, and the remainder must be green, which is 3 out of 10. So, for our second marble, since after we take out the first blue marble, then total number of marble decreases and the number of blue marbles decreases, or the probability changes. So after we take the first marble being blue, the probability of us getting the second blue marble, it will be 13 out of 19. So in this case, if our first marble is green, our probability of us getting the blue for the second marble would be 14 out of 19 and 5 out of 19 for green. So after we complete the tree diagram, we can look at B part 1. Okay, so find the probability that at most one of the marble is green. Okay, at most one of the marble is green. So, which means it's either blue and blue for the first and second, it's blue and green, or green and blue. So there are two ways to calculate this. One is add those three out, or we can use the other method, which is find the probability of green for both, and we use 1 minus the probability of that. Okay, which both ways are fine. It's just which way is easier and simpler for you. Okay, that's the method we want to use. So in this case, since we just need to 1 minus minus the one possibility, which is both are green, that itself is shorter and easier. I'll be doing that. Okay. So in this case, how do we solve it? Is the probability, which is 1, minus the probability of us getting both green, which is 3 out of 10, multiplied by 5 out of 19. And that will give us 35 out of 38. So that's the probability of us getting at most 1 green marble. Okay. So B part 2. Okay. So in this case, they say that find the probability that the second marble drawn is blue. So in this case, we don't care what marble you get on the first round. Okay. We only care about the second marble being blue. So there are only two possibilities. First round get blue, second round get blue. Or First round get green, second round get blue. Okay. So in this case, we just need to add the probabilities up. Same thing. So the first round blue, second round blue, it will be 7 out of 10 multiplied by 13 out of 19 plus 3 out of 10 multiplied by 14 out of 19. And that should give us 7 out of 10. So the probability of us getting second marble that's drawn that is blue is 7 out of 10. Okay, moving on. This is question 7. So in this case, there are 30 students in class, 20 students study geography, 15 study history, and 3 study media. So in this case, if you see, this is our sets, which we had covered previously. Okay, so we got to figure out how do we do this. So 20 study geography, 15 studies history, 3 study media. Okay. So in this case, part 1, they ask you to find the number of students who study both geography and history. So we know 3 study media. So this will be outside. Three of them will be outside. So for those who study geog or history, okay, there are total of 27 students. Okay. But in this case, there are 20 who study geog, 15 who study history. So in this case, we know that if we were to add up both geog and history, based on the number itself, it will give us 35, which is more than 27. So in those calculations, there are some who took both. So how do we find out how many students who took both? Is this. First thing, for part 1, we add both geog and history together, which is 35. So those extra students must be students who study both geog and history. Okay, so how do we find how many extra students is using the total, which is 35 minus 27, and that should give us 8. So in this case, 8 students study both geog and history. So in this case, in the center is 8. So number of students who study geog is 12. Number of students who study history is 7. So our part 1, the number of students who study both geog and history is 8. And for part 2, complete our Venn diagram, which we have completed as well. Okay? So next, 8. Question 8. So it says in part A, a bag contains 60 balls, some of which are red, some are blue, the rest are yellow. The probability of us drawing a red ball and a blue ball are 1/6 and 1/5 respectively. So the red ball is 1/6. Blue ball is 1/5. Then the yellow ball must be the remainder probability, the remaining probability. So we use 1 to minus 1/6 and 1/5. That will give us 19 out of 30. Okay. So for part 1, the probability of, find the number of yellow balls. So we know probability is 90 out of 30, and we have a total of 60 balls. So we multiply them together, we'll get a total of 38. So there are a total of 38 balls. Okay. Part 2. In this case, it says that if X yellow balls are removed from the bag so that the probability of drawing a yellow ball from the remaining ball becomes 19 out of 20, find X. Okay. So in this case, X number of yellow balls are removed and the probability of us getting yellow ball becomes 9 out of 20. So in this case, how do we solve it? It's this. Firstly, we find the number of red balls, okay, which is 10. Number of blue balls is 12. Okay. So in this case, we know there are 10 red balls, 12 blue balls. Okay. So we'll make use of these two information because these two information are the one that stays constant. That after removing the yellow balls, number of red balls and the number of blue balls stays the same. So we'll make use of this. Okay. So in this case, we know probability of yellow ball becomes 9 out of 20. So that means the probability of red plus blue ball must be 11 out of 20. Okay. And based on that, we have a total of 22 red plus blue balls. Okay. So in this case, we have 22 red plus blue balls, which is a probability of 11 out of 20, which means the number of yellow balls must be 18. Okay? So if 22 balls is 11 out of 20, 18 balls must be 9 out of 20. So in this case, after removing X number of balls, we are left with 18 balls. So that means 18 is the final number. So that means 38 minus X equals to 18. With that, we can find X equals to 20. Okay? Following that, B part 1. Okay? It says that a bag contains 8 red balls, 6 blue balls, and 3 yellow balls. A ball is chosen at random and then replaced. Means after it's taken out, another ball puts in, being the same colored ball as being put in. So which means the probability stays the same. Okay? So they ask, what is the probability that it is a blue ball? So we know there are 6 blue balls and there are a total of 17 balls. So that means the probability of it is 6 out of 17. Okay? B part 2. How many more yellow balls must be placed inside the bag so that the probability of choosing a yellow ball is 1/3? Okay? So we want the probability of choosing yellow ball to be 1/3, which means since same thing is similar to our A part 2, the change is in the yellow ball. And what we want to look at is we want to look at the thing that is fixed, which is red and blue balls. So red and blue balls, their total is 8 plus 6, which gives us 14. So that means 14 balls, that itself represent a probability of 2/3. So that means if we want to look at 1/3, that means 14 divided by 2/3 times 1/3. Okay. So in this case, our 1/3 is 7. So in order to have a probability of 1/3, the yellow ball must have 7, which means currently you have 7. I mean, at the end of it, it must have 7. Currently you have 3. That means we must add in 4 more. So the answer is 4. 4 more yellow ball must be added. Okay. Question 9. Okay, this is a bit big. Okay. So in this case, it says a bag contains $13 notes. 5 of them are $5, and the rest are $10 notes. $2 notes are drawn at random. So 2 notes are being drawn at random, one after another without replacement. Same thing. If without replacement, it means the probability changes every time each note is drawn. Okay. So in this case, they want you first thing, find your X, Y, and Z. Okay. So in this case, we know that there are five $5 notes, and remaining is $10 notes, which is 8. Okay. So for X, where after the first drawn is $5 notes, the second drawn, the probability of X, the probability of $10 notes is 8 out of 12. And it's 12 because we have removed 1 note, which is the $5 notes. And simplest form is 2/3. So that means X is 2/3. Okay, let me write. X equals to 8 out of 12, which is 2/3. Okay. So Y is the first note withdrawn is $10, and the probability of second note being $5 is 5 out of 12. That doesn't change. The $5 notes, the probability of $5 notes doesn't change. And our Z, first note drawn is $10 note. The number of $10 notes remains is 7, and total is 12. So XYZ has been found. Okay. Next, part B is this. What is the probability that the total value of 2 notes is $15? So in this case, the only way to make $15 is first note being $5, second note being $10, or first note being $10, second note being $5. So we find the probability of each possible outcome, and we add them together. So which is 5 out of 13 being the first note being the $5 multiplied by our X, which is 2/3, where our second note being $10. Then we add 8 out of 13, which first note being $10, multiplied by our Y, which is 5 out of 12, where our second note being $5. And that will give us $20 out of 39. Okay? So this is a probability, our probability where the total value is $15. Okay, next, this is our last question for today. So it says that in a box, there are four cards numbered 2, 3, 4, and 5. In box A, there are 4 cards numbered 2, 3, 4, and 5. Box B, there are 3 cards numbered 6, 7, 8. A card is chosen at random from box A and another is chosen from box B. The product of two numbers in the card on the card is recorded. So we complete this table. So in this case, it's basically the number from box A multiplied by a number from box B. So we just need to complete this table. 12, 14, 16. Okay, so we have completed this table. Okay, so next, our part 2. Using a possibility diagram, which you already have, or otherwise find the probability that the product of two numbers on the card are odd. So ultimately, our product needs to be odd. So in this case, we need to find number of odd numbers. So which is 1, which is 21, and 35. So there are only two numbers out of 12 numbers. So the probability is 2 out of 12, which is simplified 1 out of 6. Okay, part 3 is this. The product of two numbers on a card is a multiple of 3. So the multiple of 3, we have this, which is 12, 18, 21, 24, this 24, 30. So in this case, 1, 2, 3, 4, 5, 6. There are a total of 6. So 6 out of the total 12, which gives us half. So lastly, part 4 is the number of one card is even and the other is odd. So one card is even, the other must be odd. So it's 2 and 7, 3 and 6, 3 and 8, 4 and 7, 5 and 6, 5 and 8. Same thing, there are 6 out of 12, which gives us half. Okay, so that's for part 4. So that's all for today. Thank you.